Hello, we're the mathematicians, and this is a math class. You must have touched yourself once while playing Monopoly, Yahtzee, or whatever luck-based game. What are the odds? Well, that's what we're going to say today. We can use maths to measure lots of things. Lengths, growth, using functions, and angles are examples. And we can also know, using maths, the chances of something happening. This is called probability. So how is it done? Well, suppose we have a fair, six-sided dice. When I say it is fair, it means there is no trick. It is likely to land on any of its sides equally, and they are all different numbers. When I roll it, what is the probability of the side facing up being a 4? To answer this question, you must first know how many equally likely possibilities are there for the single event of rolling dice. Given that it is a six-sided dice, they are 6 in our case. Then how many possibilities meet my condition or conditions? This time it is 1, because as I said, all sides are numbered differently, so there is only one 4. So our probability of getting a 4 is 1 over 6. But what if I were to use 2 dice, or roll the same dice twice? A little tongue twister there. For this case, we're going to use a 4-sided dice, fair as usual, to make things more simple. You'll see later why. In general, the same rules apply for any number of dice, or any probability at all. This means that you still need to know how many equally likely possibilities are there and how many of them fit what you want. Suppose you want to know what are the chances so you get a 3 in either row of the dice. In the same manner we did with the 6-sided dice, we're going to count possible outcomes for these 2 rows. Keep in mind though that there are always 2 results on the same block. One for the first row, another for the second row. Now, it seems fitting to make a table with all the possible results. In our case, it will be a 4x4 table, making it 16 possible outcomes. And that is why we didn't use a 6-sided dice, because 36 results is quite a lot. In our table, each column pins a result for the first row, whereas each line does the same thing with the second row. Now, there is nothing to be worried about. The only changes compared to our first example are the numbers. The procedure is exactly the same. We already have our number of possible outcomes, 16, and now we need our desired outcomes. As we're looking for any result that contains a 3, we can count it. We have 1, 2, 3, 4, 5, 6, and 7. And although one of them has 2 3s, it only counts as one desired outcome. Then, our probability of obtaining a 3 in 2 rows of a 4-sided dice is 7 over 16. However, probability is not limited to luck-based games. We can also use it to predict some natural events. Suppose a cat is looking towards playing with a single ball of yarn, but there are 5 of them in a box. 2 red balls, 2 green balls, and a blue ball. What are the odds of the ball taken being blue? Considering, of course, the cat hasn't any preference in color or any other things that may turn this event less randomic. Well, it goes the same as usual. List the outcomes, look for the ones that suit the conditions, and voila, you have your probability. We've got 5 balls, only one of them is blue, so the probability of the cat getting a blue ball from the box is 1/5, or 20%. Now, if we have more boxes, it gets trickier. The cat now disposes of 2 boxes with 2 balls, 1 red and 1 green each. He fetches a ball from the first, drops it inside the second, and picks a ball from the second box. What are the chances of the ball picked in each box being red? To do this, we must look at each event separately. When he fetches a ball from the first box, it is an event which affects directly the second fetch. So, we have 2 possible outcomes from the first event. He can fetch either a green ball or a red ball. The green ball doesn't interest us, so the chance of him getting a red ball is 50%, or 1/2. Now, inside the second box, we have 3 balls, 2 red and 1 green. Considering that we only want red balls, the chances of him getting a red ball from the second box is 2/3. Now, we need to know the total probability. So we need to multiply them. The probability of the first one, 1/2, times the probability of the second one, 2/3, totalizing 1/3, or 33.33, and goes on infinitely %. That's the probability of getting a red ball from both boxes. So remember, every time you want to know the chances of something coming out in your favor, consider which results are in your favor and how many results are possible. That way, you won't be beaten without knowing how likely it was for you to be beaten on your, I don't know, Yahtzee game. See you next time.